Hello and welcome. This is Chapter 2, Section 5, Rational Functions, Part A. Today we're going to be finding the x and y intercepts of rational functions, determining vertical and horizontal asymptotes, and stating the domain and range by analyzing the function's behavior. So asymptotes. The first one we're going to talk about is a vertical asymptote. A vertical asymptote is a line the graph will get infinitely close to but never touch as x approaches some value. For these rational functions we're going to be talking about, vertical asymptotes occur where there is 0 in the denominator. And this will have infinite discontinuity is what it kind of entails. To find them, we're going to look for the values of x that make the denominator 0. So that's our main goal for here. So there are horizontal asymptotes as well. That's a line of the graph approaches x as it goes to positive or negative infinity. So for rational functions, if the degree of the numerator is less than the denominator, the horizontal asymptote is always y is 0. And if the degrees happen to be equal, the highest degree, the leading terms of each, then the ratio of the leading terms of the denominator and the numerator, and that will be our horizontal asymptote. So you'll take the leading coefficient of the numerator and the denominator and divide them, and we say y equals that, and that will be that left and right or horizontal asymptote. If by chance any of that doesn't occur, then there are none. So if you have the numerator higher than the denominator degree, then there will be none. So let's just look at these quickly. So these dashes are going to be asymptotes. So this one's approaching it vertically. This is a vertical and another vertical asymptote. That's a horizontal asymptote. So we're going to just show or explain what they are. So looking at this one right here, this one, those are vertical. This one is a horizontal. So what are those? Well, the vertical ones, we look at the number where here x is going to be -4, so x equals -4 is my first one. This is +3, so x equals +3 is my next one. Now the horizontal is going through 0, so that is just y equals 0 for that. Now we're looking for intercepts on the graph, so we have an intercept here for our y. We have an intercept here for my x, and that's the only two things I see. So at +1, that's my y-intercept, and at -2, that's my x-intercept. So I'm just looking for those. And then what is the domain of this? What can't it be? So remember, x will not be able to be this number, which is -4, and x cannot equal +3. Because these will approach but never touch, approach but never touch, approach but never touch, and this approaches but never touches. So we cannot be equal to those. It's undefined at those locations, so my domain is from -infinity all the way to -4, union, sorry, that should be a union symbol, and then we go from -4 to +3, and then we go from +3 to infinity for my domain. Now my range, notice how this graph keeps going from ever upwards all the way down here, flattens out. This one goes up and all the way through. So because it's going, this part is going everywhere, it doesn't matter. You just choose kind of piecing them all together. So this one, if we just look at these outsides, it doesn't include 0, but the middle part actually can be 0. So if you plug in 0, you actually get 2 for the y value. Or sorry, if you plug in x as 2, you get 0 for the y value. So you do get 0 actually. So it actually includes everything for my range. So it's -infinity to +infinity. So see if you can go ahead and check your own answers on this one. See if you can try it. Pause it. I will have answers shortly. So if you tried it, you should have got these. We got x is 2 and -1. Notice how there's nothing in the middle, so we actually can't be equal to -1 for my range. So that's where we have that out of there. It also can't be equal to +2. We can't equal any of those for our range or domains here, so we would have those as my range and domain. So what we're going to do is we're going to actually graph the asymptotes. So in this case, let's talk about both the vertical. The vertical are always the easiest, I think, and then we're going to talk about the horizontal. And in this case, the vertical is just what makes the denominator 0. So we're going to just say, what's this? X plus 5, set it equal to 0, and then we get x equals -5. That is my vertical asymptote. So you go to -5, and we do a dashed line through -5. So that is x equals negative 5. Now, our next one, because the horizontal, notice how the numerator is a lot lower power, so the degree is higher on the denominator. If that's the case, we always have y equals 0 as our horizontal asymptote. And the reason why is if we plug in values of large numbers such as infinity or negative infinity, it's going to flatten out at the end. It's basically what is the end behavior of this function, which is what we're looking at for horizontal asymptotes. So if I plug in infinity, like negative 10 over a very large or very small number will be basically 0. As we approach infinity or negative infinity, it is essentially 0. So again, let's go ahead and do another example. Let's do the vertical first. So we just take the denominator and put it equal to 0. So we get 3x is 9, divide by 3, and x ends up being equal to 3. So positive 3 is my vertical asymptote, so we draw that in. And now my horizontal, notice how they are both the same thing. So when we do this, the horizontal, if the degrees are the same, so we take y equals the leading coefficient of both of those over each other, which just gives me y equals negative 1 over that. So remember, when we talk about large numbers, infinity or negative infinity, and the end behavior, this plus 7 or minus 9 doesn't really mean much, so we kind of cancel them out when we talk about infinite numbers, and we just have negative 3x over 3x, which the x's cancel out or become 1, and then we're just looking at negative 3 over 3, those leading terms coefficients. So y is negative 1 will be that asymptote that's horizontal here. So let's go ahead and do examples 4 and 5, and we're just going to find them, and you can graph them just like we did before. So first off, the vertical one, remember we take the denominator, we set it equal to 0. Can this ever be equal to 0 if x is a real number? Well, just remember, if you solve this, x squared is always positive and it can't be negative, so there are none for my vertical asymptotes here, because remember, x squared is always positive if x is a real number, and we will assume that these are real numbers because we can't graph not real numbers on a real axis. So our horizontal then, we look at, well, the top has an x and the bottom has x squared, so the denominator has a higher power. So if the denominator is always bigger, that means that we have y equals 0 for that. Now the vertical here again, so we take the denominator, we set it equal to 0, we add and divide, so we actually get x is in fact equal to negative 3/2. If we add 3, divide by negative 2. And horizontal, the numerator is in fact higher than the denominator, so this will have none because the numerator has a higher power than the denominator here. So I'd like you to check this one, and one of my key hints is try to factor the denominator. That might be very useful. And find the horizontal and vertical asymptotes. Pause it. I will have answers shortly. So hopefully you tried it. Again, the bottom, it's easy to set to 0 and you can factor it. If you needed to, use quadratic formula, but we should get x is 3 as a vertical line and x equals negative 2. You, in fact, need x equals for both of them because they are lines. Same with this. You take the two things because they're the same powers or the same degree on numerator and denominator. We take the coefficients front, 3 and 1, divide them, which is just 3. Y equals 3 is that horizontal asymptote. So our last example today, example 6, is finding all of the asymptotes. So the first one is, let's do the vertical. That one's always the fun one to do because it's just say, hey, what's the bottom? Set it equal to 0. So in this case, we get x is subtract 1, divide by 2 is negative 1/2. That is my vertical asymptote, so very easily. Now notice how the numerator is in fact larger than the denominator. So there are no horizontal asymptotes. So that is one thing to notice. But if the numerator, so if the numerator is higher, is one, let's say 1 degree higher, 1 degree higher than the denominator, this will imply there is an oblique or slanted, oblique, which is considered a slanted asymptote. So what we need to do to find that is we're going to have to use long division. To find oblique or slanted asymptotes, we will have to use long division. So we're going to say 4x squared, our dividend, plus 8x and minus 9, and we will be dividing by that divisor of 2x plus 1. There are two x's that go into 4x squared, so this becomes 4x squared when we do our long division, and that's plus 2x. Remember, we subtract those, and we get that this is 6x and minus 9 after we drop that. How many 2x's are inside of the 6x? Well, that is plus 3 of them. So this becomes 6x. Let me move this up a little bit so I can actually write. So this becomes 6x, and then 3 times that is positive 3, and we subtract that, and this becomes a negative 12. Now this remainder doesn't really matter, so we don't really need to this, because as we approach our end behavior, a slanted asymptote is going to go this way and this way, or this way and this way, and we're going to look at the ends of where it goes, because the function we'll be talking about the end behavior, so this negative 12 doesn't really matter, and we're only going to focus on the quotient. So what that quotient is, this oblique asymptote will be just y is equal to this 2x plus 3. And how do you graph that? So if you don't remember how to graph those, so the first thing is we can just do a rough sketch. Our first one was at negative 1/2 for that vertical. So if we do a vertical here, let's go at this as negative 1. This is positive 1. Let's do 1, 2, and 3. 1, 2, and 3. Let's just do a couple numbers. So we have them. So our vertical asymptote will be right here at x is negative 1/2. Our slanted asymptote, we're going to do our 3. We're going to our positive 3 and rise over run. So we can do up 2 over 1 or down 2, left 1. So I am going to go down 2 and left 1 and have a dot here. Or we could go up 2 and left 1, which is somewhere out there. So this would be my oblique asymptote. So we'd have our two asymptotes like this, and it will provide a region here, here, and here, and the graph will either be in here and here, or up in here and up in here when we actually eventually graph these. So please go ahead and try to rough sketch these, find the oblique and the vertical asymptote. Pause it, I will have answers shortly. So if you tried it, it should look like this. You should get x equals 2 as that vertical, and oblique is y equals x plus 3 once you do long division. Again, we don't care about the remainder as we talk about infinity or negative infinity. So we'd plot the 3, our y-intercept, and up 1 over 1, up 1 over 1, and this would be our oblique asymptote. So here's just a recap of how we talk about horizontal asymptotes. So if you wanted some definite rules, this is kind of how you can look at them.